Now we move to the next part of our lesson, section 3.3. So we are going to discuss about simple harmonic motion. Okay. So what is simple harmonic motion? Simple harmonic motion, or in short, we say use the short form SHM, is motion in which the acceleration of a particle P is always towards the fixed point O on the line of motion of P and has magnitude proportional to the displacement of P from O. So are you following this, what they're saying here? So what are the special things about simple harmonic motion? So there are several key things here. What are they? Number one, simple harmonic motion is a motion where the acceleration is what? Is always towards the fixed point O. The acceleration is always towards the fixed point O on the line of motion of P. And also what are they saying? There's another extra thing they say here. They say this acceleration, the magnitude is what? Proportional to the displacement of the particle from O. So basically it's proportional, means it's directly proportional, meaning the displacement. So if you are displaced, the higher the displacement, the higher the acceleration. Can you understand? So acceleration is not constant, it's a acceleration that is proportional to the displacement. And also what's the other important thing? In SHM, the acceleration is always directed towards the center. Okay, so a good example of simple harmonic motion that you can normally practically understand, maybe the simple pendulum, right? You know, I think you might have heard of the motion of the simple pendulum. In the case of the simple pendulum, just to give you, it's not related to this over here, but just to give you an idea of what SHM is, because we are going to be discussing the simple harmonic motion in springs and strings. We will be discussing SHM in elastic strings and springs. Okay, but just to give you an idea of how the motion works in like in a simple pendulum. Okay, so this pendulum, you know, it's going to move in an arc, right? Okay, so it's going to move in an arc like this. Do you agree to these two directions? Okay, so it's so this is an example of SHM. Why? Because this, whenever the pendulum moves away from the center, you can see the speed, the magnitude. Is it getting higher or is it getting lower? The more it goes away, the speed gets lower. Why? Because we know in SHM the acceleration of the particle is always towards the origin. So this is the point O. The acceleration is always towards this point O. So when you're moving away from the origin, you will be slowing down until you come to the point where you until you come to the like we use the word amplitude. I will come into those terms in a while. So then afterwards, when you're coming back towards the origin, you will come back, you will gain in speed, isn't it? You'll come back gaining in speed, and then again you'll move to the other side. You'll move to the other side anyway. So we'll go into the more important part. So we will be discussing SHM in strings and springs. Okay, so let's go into that. I will give you more information about that as we move into the lesson. Okay, so right now at this point, all I want you to realize is what is SHM. The acceleration is always directed towards the center, which means if you are moving away from the center, you are going to slow down. And when you're coming towards the center, you will speed up. You'll speed up. Okay, so there we will be discussing more in depth about this in a moment. So right now, let's go into the equations that we can derive from SHM. Okay, so first one is, they did use the word the acceleration is proportional to the displacement, isn't it? Do you see this? The acceleration is proportional to the displacement, which means what? Which means, I think you can see here, they are using this notation x double dot. So who is x double dot? X double dot is actually, you know, x is displacement, right? X is displacement. So the notation x dot is used to, where we use the notation x dot to denote when you differentiate x1. So basically x dot in other words is dx by dt. X dot represents differentiation of x with respect to t once. So what does x double dot represent in that case? X double dot is when you differentiate with respect to time, you differentiate x twice. So what do you get when you differentiate x twice? You know, when you differentiate x once, you get dx by dt. Who is this? Dx by dt is also the velocity, isn't it? Velocity is dx by dt. So when you differentiate the x term twice, d square x by dt square. Who is that? Who is that? Differentiating x twice. When you differentiate x twice, You know, when you differentiate x once, it's velocity. Differentiate it twice, and you get acceleration. So basically, d square x by dt square is acceleration. So x double dot, in other words, is the acceleration. And can you see what? Can I just look at the equation they've given here? They're telling you here the x double dot. See the way they have derived is equal to minus omega square times x. Okay, here omega is a constant. Omega is a constant. Okay, omega square is a constant. Why have they given the negative sign? Why have they given the negative sign? The negative sign is because the acceleration is directed towards the origin. Do you recall this from the first chapter? If the acceleration is directed towards the origin, we gave it a negative sign. If it's directed away, it was positive. So in SHM, you will always see x double dot will be coming with a negative sign when you consider the directions, because it's always directed towards. And the convention is, we say away from the origin is, okay, away from the origin is positive, towards the origin is negative. The minus sign means that the acceleration is always directed towards O. That's why you have the minus sign here. Omega is a constant. Why? Because they say here the acceleration is proportional to the displacement, isn't it? Can you see the acceleration is proportional to the displacement? X is the displacement from the point O. And then the constant. So to remove the proportional mark, we have put the constant. So it's a negative constant. Why is it a negative constant? Because the acceleration should be directed towards the origin. Okay, so the constant is used to get rid of the proportional sign to make it equal. So this is the first main equation that we will be using in this lesson. What's the first main equation? So this is something that we will be using a lot. Okay, so whenever any object, if it moves in SHM, it must have its acceleration function following this format. Okay, so that's really important. Okay, once again, if there's any object that moves in SHM, its acceleration, the x double dot, must be following this format. So x double dot must be looking like x double dot equal to minus some constant times x. So if there's any function that looks like this, then that particular object, that particular person is moving in SHM. So this is the first main equation that you need to know in SHM. Okay. Okay, so then you can see in the next part, they have said this can be shown on a diagram. Okay, so looking at this diagram, can you see this O is what we represent as the origin? Can you see? And then you are moving away from the center. So, but when you're moving away from the center, okay, so when you're moving away from the center, the acceleration is directed towards the center. Can you see that this double arrow over here? So when with two arrows, normally we talk about the acceleration with two arrows. So the acceleration is directed towards the center. So if you're moving away from the center, what does it mean? It means you will be slowing down. It means you will be slowing down. And if you're coming towards the center, it means you will be speeding up. Okay. The thing is, so then, okay, let's talk about this. So we're going to derive some equations. So in the next part, we are going to derive some main equations that we will be using to help us with simple harmonic motion. Okay, so let's see. As x double dot is a function of x, you guys can see x double dot is a function of x, right? It's a function of displacement, acceleration. So you do remember in chapter 1, if your acceleration is a function of x, there was a equation that we used, right? What was it? X double dot, if it's a function of x, do you recall the equation in chapter 1 kinematics? You learned the acceleration, if it's a function of time, we use acceleration dv by dt. If acceleration is a function of displacement, we use it's equal to, do you recall? V dv by dx. Is this okay? So this is something that we learned in chapter 1. Okay, so now what I'm going to do here is, as you can see, I'm going to prove a main equation. So let's just learn how to quickly do this. So what I'm going to do here is, we know our acceleration x double dot is also equal to minus omega square x, right? Do you agree? X double dot is also equal to minus omega square times x. Omega square is a constant, x is the displacement. So what am I going to do here? I will equate these two. So v dv by dx equals minus omega square times x. Do you agree? Okay, so now what I'll be doing here is, I'll be separating the variables. Guys, look. So v times dv I'll be taking the dx. Can you see this dx? I'll be taking the dx to the other side. So what do we get here? Minus omega square x times dx. And I'll be integrating. Can you see? So this side will integrate with respect to v and the other side will integrate with respect to x. Okay, so then let's integrate. So when you integrate with respect to v, you'll get here v with respect to v, you'll add 1 to the power, right? V square over 2. So it's going to be v square over 2 equals, here minus omega square is a constant. I told you omega square is a constant. So you'll be only integrating the x. So when you integrate with respect to x, what do you get? X square over 2. And then you'll have to use plus c. Do you agree? Okay, so you'll have to use plus c. Okay, so now we need to find the value of this plus c. We need to find the value of this plus c. Okay, so how do we find the value of the plus c? Okay, so to find the value of the plus c, I'll have to go back to the simple harmonic motion and explain you the full motion. Okay, so let's come back to the motion and let me tell you how to find the plus c. Normally, to find plus c, we need some kind of a boundary value, right? So we need, for example, you can see here how variables are velocity v at x. So I need the velocity at some x value, isn't it? I need the v at some x value in order to find the c value. Okay, let's see how we can do that. Okay, first let's consider a simple harmonic motion. Look at this. So how will SHM move? You can see here, yeah, SHM is always having a center. So I'll say the center is O. And what was the rule? So when you're moving away from the center, you'll be slowing down. You'll be slowing down, and eventually what will happen? You will come to the object. The particle will come to at the very corner. What do you expect? So now the particle will move over here, and when the particle moves away from the center, it will slow down, isn't it? It will slow down, decelerating because the acceleration is towards the center. It will slow down, and it will eventually come to rest. Do you agree? At this corner, it will come to rest, and this is the maximum displacement. This is the maximum displacement, and then after you come to the maximum displacement, what happens? You again start making the journey back towards the center. So you start making the journey back towards the center. Okay. So when you start making your journey back towards the center, what's going to happen? You will come towards the center with what? You will come towards the center with a, you're accelerating. It's not just a normal acceleration. It's a variable acceleration. Okay. So I will talk about the acceleration in a moment, but you are going to come towards the center with the speed. The speed will increase. The velocity will increase. And at the center, after passing the center, what do you think will happen? After you pass the center, you're again moving away from the origin. Again, you're moving away from your center. So if you're moving away from the center, you'll again be slowing down, which means again, on the other side, you'll have another position where you have what? On the other side, again, you have another position where the velocity is 0. Do you agree? So over here, I need you to understand how SHM works here now. So basically just keep like imagine the motion of the pendulum. So when you're moving away from the origin, it's slowing down. And when you come towards the origin, when you come towards the center, you will speed up. And at the center, you will have what? What speed? You will have the maximum speed. Guys, do you agree on that? At the center, you will have the maximum speed, isn't it? Because at the center, okay, you will have the maximum speed because you come here, you come up speeding over here, so you come to the maximum speed. And you know, the moment you pass the center, when you go away from the origin, when you start making the journey over here, you're moving away from the center. So when you move away from the center, you'll again, since the acceleration is directed towards the center, you'll be slowing down, and you come to the point where the velocity is 0. And now what happens? Again, you start making your journey towards the center. So when you start making your way towards the center, you'll be speeding up. You'll be speeding up and you'll be speeding up, and until you come to the center, you'll be speeding up. And then you reach the maximum velocity. And then, so obviously when you reach the maximum velocity, you cannot stop there. It needs to continue moving. But when it now continues to move, it's going to lose its speed because it's moving away from the center. It loses its speed until it comes again to the corner where the velocity becomes 0. Okay. So then we say the, so we are going to give some notations here. The maximum now, the displacement is measured away from the center, right? The displacement, the x is measured away from the center. So we use the maximum displacement away from the center. We will give it a special term. We are giving it the term A, or in other words, it's also known as the amplitude. The amplitude of the simple harmonic motion is the maximum displacement that your object will move away from the center. Are you with me? So the x value, so the maximum x value you can have here is A. Is that okay? Okay, so this is the standard letter that we use over here. So A represents, remember, in SHM, A doesn't represent acceleration. Acceleration in SHM is always represented by x double dot. Okay, wherever you see A in this lesson, the A represents the amplitude. Okay. Okay. So then, so this SHM is a motion. Actually, you can see that it's going to continue moving in this manner. Can you guys see? So over here, these are the 2 points where the velocities are 0. At these 2 corners, you will have the instantaneous rest point, and it's going to continue more like a spring. Like a spring moving in this particular motion. So it's going to move in that manner. Okay. And then the thing here is maximum displacement is A. The amplitude, it's just the name given. So basically, this length is called amplitude. It's just the maximum displacement from the origin. The maximum displacement away from the center is called the amplitude. Okay, it's just the name given to it. Okay, so what's special is at the amplitude, the velocity becomes 0. And you guys can see when x is 0, so I just want you all to know this. Okay, over here you can say at the maximum amplitude, we can see when x is A, when x is equal to A, the velocity is equal to 0, isn't it? Do you agree? When x is equal to A, velocity is equal to 0. And also you can say when x is 0, what happens to the velocity? What happens when the displacement is 0? When displacement is 0, it means you are at the origin, right? And what happens when you are at the origin? When you are at the origin, you have the maximum velocity. You will be reaching the maximum velocity. So this object, it always wants to come towards the center, but it can never stay at rest at the center. Do you agree? It wants to always come towards the center, but just because it wants to come towards the center, since it speeds up when it comes towards the center, it will always have to pass the center and go, because when you reach the maximum velocity, it cannot stop here, right? It continues to move to the other side, and then it will again start losing speed. So I was all this time talking about the velocity. Now I also want to talk to you about the acceleration. So what about the acceleration? We were told in SHM, the acceleration is what? Is the acceleration is always directed towards the origin, and the acceleration is proportional to the, what was it? The acceleration is proportional to the, they've told us the magnitude of the acceleration is proportional to the displacement. Can you see? Because you need to, the first thing you need to understand here is in SHM, you don't have constant acceleration. The acceleration is not fixed, not constant. So acceleration will vary with displacement. That's why we wrote this, right? Acceleration is a function of displacement. So which means what? Which means the higher the displacement, the higher the acceleration, which means where do you find the maximum acceleration? Guys, where do you find the highest acceleration? Because it's not a constant acceleration. Your acceleration will vary. So where do you find the highest acceleration? You will find the highest acceleration at the maximum displacement. When x is the highest value, the biggest possible, the largest possible x value here is A. Do you agree? A and also minus A. I think if you take it to the other side, x equal plus A, x equal minus A. So over in these two sides, children, at the two corners, when the velocity is 0, you have the maximum acceleration. You have the maximum acceleration. Okay, and what happens at the center? At the center, you can see the displacement is 0. Also, you have reached the maximum velocity. So if you recall, m2, and if you recall the theories you've done before, you know when you reach maximum velocity, acceleration will be, when you reach maximum velocity, acceleration should be 0. Actually, you can see here, displacement is 0, right, at the center. So at the center, when x is 0, if the displacement is 0, since acceleration is proportional to the displacement, right? Acceleration is proportional to the displacement. You can see when x is 0, x double dot is 0, right? Do you see? Also, you know, when the acceleration is 0, it means you have reached the maximum velocity. Okay, so these are the main things you need to know here. So basically, when x is equal to a, velocity is 0, and your x double dot is a maximum. When x is 0, your velocity is maximum, your x double dot is 0. So again, these are some special things you need to know about this motion. Okay, so now what we'll be doing here is we'll be using these points to actually find the value of our c. As you remember, we were in the middle of integrating, right? So we had x double dot equal v dv by dx. Okay, so we know that of course is when the acceleration is a function of displacement, and we also know in SHM x double dot is equal to minus omega square x, because acceleration is proportional to displacement. And then I have made v dv by dx equal to minus omega square x. I separated variables, v terms on the v side, x terms on the x side, and I have integrated. And now I have to find the value of c. So to find the value of c, I'll be using the help of this. I'll be using the help of these points, because I can use the help of these points to actually calculate the value of the constant c. Okay, so let's do that now. Okay, guys. So what we need to do now here is we have these values over here. So we need to just input these values into this equation to get the value of our c. I hope you guys were able to understand how this works, right? So when you're moving, so once again, when you're moving away from the center, you are slowing down. And then you can see here, now I have told you over here, the velocity is 0, but the x double dot is the maximum, right? The acceleration, because the acceleration is proportional to the displacement. And remember, your acceleration is directed towards the origin. So because when you're moving away from the center, when you're moving away from the center, the magnitude of the acceleration, basically the x double dot is the maximum, means I'm considering about the size of the acceleration, the magnitude. The magnitude is at its largest. Okay, so when you're going away from the center, basically your rate of decelerating is increasing, isn't it? I mean, you consider it along with the negative sign, the rate of decelerating will increase. Okay, and when you're coming towards the origin, I hope you guys can also see what happens when you come towards the origin. You can see when you're coming towards the origin, your speed is increasing, isn't it? Because your speed is increasing, so you feel like you're accelerating. Yes, you are accelerating, but what about the rate of, now you can see when you're coming towards the origin, the displacement x is increasing or decreasing. When you're coming towards the origin, the displacement is decreasing, which means what? Your rate of acceleration is actually what? The x double dot value is dropping. The acceleration value drops, and when you come over here, the acceleration actually becomes 0. So I hope you understand this, that even though your acceleration value drops when you come towards the center, there is still an acceleration, which means the velocity of the object will increase, even though when you're coming towards the center, even though the x double dot value drops, even though the acceleration value drops, the velocity, because there is still acceleration, the velocity will increase. And then when you come over here, your acceleration is 0 and you reach the maximum possible velocity. Okay, so I think we'll need to do a few more sums to get this properly understood. Okay, but I hope you have some basic idea in your head at this point. So let's go through let's just go through this sum. Let's go through some examples, and I think you will be able to understand this a lot better after that. Okay, so let's go through this. Let's finish off this equation. So to find the value of c, what I'll be using here is I'll be using the help of the x. When x equals a, velocity is 0. Shall we use that? So when x equals a, let's use this. When x equals a, the velocity is 0. Let's use that. So what do we get here? 0 square over 2 equal minus omega square a square over 2 plus c. Do you agree? So then we get here 0 square over 2 is 0 equal minus omega square a square over 2. So c is equal to plus omega square a square over 2. Do you agree? So now what do we need to do here? We'll take back this equation and substitute the c value. We get here v square over 2 equals minus omega square x square over 2 plus the c value is omega square a square over 2. And now I think you can see that the half is common to all the terms here, right? Shall I remove it? We can remove half from the whole equation because half is common to every single term. So I end up getting here v square equal minus omega square x plus omega square a square. So we can take omega square out. Omega square. So minus x square plus a square, or I could rewrite this as a square minus x square. Can you guys see? So this is one of our main equations. V square equal omega square a square minus x square. So you can actually use this equation without the proof. So I have done the proof of getting this equation, but you are able to use this equation without actually going through this proof. Okay. Okay, so continuing continuing to the next part, you can see here I have highlighted some of the main things, the main formulas and the main equations that you need to know to do the something SHM. Okay, so they say for SHM of amplitude A. Now you by now all of you know what is amplitude, right? Amplitude is the maximum displacement from the center. Okay, so for SHM of amplitude A defined by the equation x double dot equal minus omega square x. Okay, so also I think you are now familiar with what this represents. X double dot, the acceleration is equal to minus omega square x, and you all know why the minus mark comes. Okay, they say here, so for motion of this particular type of SHM type motion, v square is equal to omega square a square minus x square. So this is the equation we just proved now. We just proved this equation, isn't it? Okay, so look at the remaining equations. So I did not go for the proof of the equation, rather because it's more important that you understand how to use these equations. Okay, it's not the proof required here, but the method that the way to use these equations are what you'll be tested in the exam. So they say if P is at the center of the oscillation, when T is 0, use X equals A sine omega t. Okay, what does that mean? Now, you know, in SHM, okay, in SHM, you have a center, right? In SHM, you have a center. So what are they saying here? At the start, at time 0, if your particle is at the origin, at time 0, if your particle is at the origin, now you know your particle will start moving away from the center, right? That's the whole point. You know, at the center, we have the maximum velocity. Okay, so let's say it's moving away from the origin to the left side. Okay, so when you're moving away from the origin, the displacement, you know, X represents the displacement, right? So they say the displacement follows what? The displacement follows the formula A sine omega t. Basically, the displacement follows a sine function. Remember here, A represents the amplitude and omega is a constant, which you should know, which you can find from the acceleration equation. Can you see? So if you are starting your motion from the center, if you are starting your simple harmonic motion from the center, then if you want to find the displacement, like how much you have displaced within a certain amount of time, you must use the equation x equals A sine omega t. Okay. And then they say if P is at an end point. Okay. So look at the other one. If P is at an end point, what do you mean by an end point? What are the endpoints in this SHM? This is the center. What do you mean by the endpoints? Now this particle is moving like this, right? So what are the endpoints? The endpoints are these two corners, isn't it? Which means the amplitude, right? So amplitude. So if P is at the end point of the oscillation, when time is 0, which means what? At time 0, if your particle starts its motion from the from the amplitude, at time 0, if your particle starts its SHM motion from this amplitude, They are asking you to model the displacement equation by using A cos omega t. Can you all see? This is just theory. This is just theory. All you have to do is to simply follow the theory. If your particle at time 0 starts its SHM motion from the center, you measure the displacement by using A sine omega t. If your particle is at time 0, if it is at the amplitude, to measure the displacement, you will be using x equals A cos omega t. Okay, so this is this is equation. The fourth one, if t is at some other point when t equals 0, you must use x equals A sine omega t plus alpha. Okay, so actually this is not an equation that we'll be using as much as we use the other two. Okay, so even if you start at some other point, we can use the help of the first two equations to get this. Okay, so we'll see all of these. We'll see them by using some examples. Okay, let me move to the last point first. The period of the oscillation. This is really important. Look at this. The period of the oscillation is for t equal 2 pi over omega. What do you mean by the period of the oscillation? Period of the oscillation is the time taken to complete one complete round, isn't it? So, for example, if you start from the center, let's say at time 0, you're at the center. So then how does a simple harmonic motion work? First, you start from the center, you go away, isn't it? You move away from the origin until you come to the amplitude. And then what happens? So you start from the center, you move away from the center, you decelerate, isn't it? You decelerate and then you reach the maximum deceleration, or in the sense, the maximum magnitude of acceleration. The maximum magnitude of acceleration over here. The velocity is 0 and you have the x double dot maximum magnitude. Okay, and then what happens? After you come to this point, it's an instantaneous rest. What do you do then? You start moving back towards the origin. You start moving back towards the origin. And then when you start moving back, what happens? You end up speeding up. You speed up. Of course, you will be coming towards the origin. The velocity will increase. But as you can see, the displacement, the x is measured away from the center, right? X is measured away from the center. So you can see the displacement. When you start coming back, displacement will decrease, which means what? The magnitude of the acceleration will decrease. Okay, so even though the magnitude of the acceleration decreases, the velocity, because there is still an acceleration, the velocity will increase. And what do you get here? At the center, you will again get V max. Do you agree? To the other side, you will get the V max. And now what happens? Do you stop here? No, you go to the other side. You go to the other side. You keep continuing to the other side until what? Until you come to the amplitude. So at the amplitude again, your velocity will be, your velocity will be 0. And then what do you do? After this point, you again start coming back. Again, you start coming back, and you can see you end up exactly where you started. Can you see? So this is one complete round. Starting from the center, you go to the amplitude, you come back to the origin, you go to the other side of the amplitude, and you come back to the origin. That is one complete round. And the time taken for that complete round, we call it as the period of oscillation, is what? The time taken for this complete round is 2 pi over omega. The time taken for this complete oscillation is 2 pi over omega. Are you guys with me? Capital T is the periodic time. Okay, and then one more interesting thing about the periodic time is, children, you need to understand this periodic time. You can actually break it into 4 sections. Guys, do you see this? Do you see that if you consider the time taken to go from the origin, the center, to the amplitude, do you see that it is actually from the center to the amplitude, it's actually 1/4 of the whole motion? Because you can see it's divided, the SHM is actually divided into how many parts? It's divided to 4 parts, 4 equal parts. So actually the time taken, now if the time taken for the entire journey is capital T, then the time taken to go from the center to the amplitude will be 1/4 of the periodic time. Do you agree with me? And then to come back from the amplitude to the center, it will be another 1/4 of the periodic time. And again from the center to come to this amplitude, you get again 1/4 of the periodic time. And to come back from here to here, you'll again take 1/4 of the periodic time, which means add everything together, you get the capital T. And the capital T is 2 pi over omega. So this is really important. So, okay, so remember SHM, you can only break it into 4 parts. Okay, because these 4 parts, the motion is kind of repeating itself. Okay, so you can only break it into 4 parts. By the way, is it possible for you to, for example, let's say that you now you know this maximum distance is the amplitude here, right? So what if you go half of the amplitude? Is it possible for you to take, say you have gone the half, the distance half of the amplitude? Is it possible for you to take the time as half of t over 4? Is it possible for you to take now, say you are going to take in between these 2 points, say you are taking exactly the middle, halfway. Now you know the time taken to go from here to here is quarter of the t value. So then the time taken to go from here to the middle of this, can we take it as half of t over 4? No, you need to realize that over in here, is it a constant acceleration? No, it's not constant acceleration. It's not constant velocity. The acceleration changes. The rate of change of the velocity is changing, isn't it? So because of that, you cannot expect that the time, like you need to realize here, the more you move away, the slower it starts to decelerate at a higher rate, right? So you'll be moving much faster over here in compared to what you will be moving like at this part over here, which will be quite slow. So you cannot subdivide, you cannot divide these sections any further than this. Okay, so if you want to get the times taken to travel halfway, you'll actually have to use what? You'll actually have to go with these equations. Okay, so for now, all I want you to understand is you can only divide the simple harmonic motion time into 4 sections. You cannot subdivide it any further. If you want to find the time taken to go from here to the middle of this point, you'll have to go with these equations because these equations contain time and you can find the time. Okay, so other than that, you can only break the simple harmonic motion, the time into these 4 sections. You can break the periodic time into 4 parts only. You cannot divide any further than that. Okay, any times you want over here in the middle should be found by using this formula. Okay, so let's actually go over the sums and see how these theories are applied. Okay, so now I'll move to exercise 3C. So we'll do some questions with this. We'll try to understand simple harmonic motion further. So I was explaining the theories before, but I think you'll need to do these sums to understand this concept further. Okay, so let's do some questions to understand this properly. Okay, so they say here, a particle P is moving in a straight line with simple harmonic motion. The amplitude of the oscillation is 0.5 meters. Shall we draw this first? So let's draw this. So this is the simple harmonic motion. So center passes through the center of the oscillation. Oh, sure. So let's mark everything. A particle P is moving in a straight line with simple harmonic motion. The amplitude of the oscillation. So amplitude means the maximum value of the displacement is 0.5 meters. Okay, and P passes through the center of the oscillation with speed 2. Guys, so when you see that it passes through the center of the oscillation with speed 2, what do you understand? I told you when you pass through the center, you have what speed? Whenever in SHM, when the particle passes through the center, you have the maximum speed. So over here at the center, you have the maximum speed. Okay, you have the maximum speed, which means the Vmax is how much? 2 meters per second. Your Vmax here is 2 meters per second. Do you agree? Okay. So they're asking you to calculate the period of the oscillation. Okay, the question is to calculate the period of the oscillation. Okay, how do we calculate the period of the oscillation? So what's the period of the oscillation? The equation for to calculate the period means is what? T equals the equation. The period of the oscillation is given by T equal 2 pi over omega. So these are equations that you need to memorize, that you need to know. Okay, so T equal 2 pi over omega. As you can see, 2 and pi are constants. Even omega is a constant. But 2 and pi are known constants, isn't it? Pi is a constant that we know the value. But omega is a constant which you must find. You have to find the value of this omega. How do we find the value of omega? So to find the value of omega, what I'll be doing is I'll be using the help of the first equation. What's the first equation that we built? V square equal omega square, a square minus x square. You can clearly see that you have at the maximum speed. I think you know x is measured away from the center, isn't it? X is measured away from the center. So what happens at Vmax? At the maximum velocity, your x value is, you get the maximum velocity at the center, right? So when you're at the center, x is measured away from the center. So if you're at the center, x will be When you are at the center, x will be 0. When you are at the center, x will be 0. So what you'll be doing here is you'll be using the value when v is 2, when x is 0. So use that. You get 2 square equal omega square a square. Amplitude, you know, 0.5 square minus x is 0 square. Guys, can you see what I just did over here? I replaced the value of v, a and x because I considered a point where I knew the v and x value. And now we can easily find what? The value of omega. So 2 square is 4. Omega square into 0.5 square is 0.25, right? Can I know the value of omega square? 4 over 0.25 is 4 over 0.25 is 16, right? Which means omega is root of 16, which is 4. So omega is a positive constant. Take the constant 4. So omega is 4. And then what do we do? To get the periodic time, T equal 2 pi over omega, which means periodic time is 2 pi over omega is 4. Periodic time is pi over 2 seconds. So the time taken to complete one full oscillation, if you start from the center to go to the amplitude, come back to the center, go to the other side of the amplitude and come back to the center. That is the complete oscillation. You'll be taking pi over 2 seconds. Okay. Part B, they ask you to find the speed of the particle when OP is 0.2 meters. So obviously OP is 0.2 means you have moved the distance of 0.2 when x is 0.2, right? Can you see? So when you have moved the distance of 0.2, they are asking you for the velocity. How do you get the speed? Basically the speed. In the sense of the speed, we just need the magnitude of it. So how do you get the speed? We can use the help of v square equal omega square a square minus x square. So what is the answer? Omega square answer we just found. Omega square, omega is 4, omega square is 16. Amplitude is 0.5. Amplitude is a constant, remember. Amplitude is a constant for this particular sum. Only x and v are the variables. Okay. Remember, x and v are the variables. Okay. The omega value, the a value, these guys are constant. So amplitude square minus x square. So you can see when OP is 0.2, what do we have here? We have the x value, isn't it? Because x is the distance measured away from the center. So x is 0.2 here. And now what do? We have to make v the subject. So what is the value of v? 16 times 0.5 square minus 0.2 square. Get the answer. So v square, when you type this in the cal, you get 3.36. V is the root of 3.36. So what's the root of 3.36? Square root of the answer is, you get a big decimal. So you can round it off. 1.83303. It goes on. So round into 3SF, 1.83 meters per second. Correct to 3 significant figures. So this is the speed. This is the speed of the particle when it has moved a distance of 0.2 meters away from the origin. As you can see, the speed has dropped. At the origin, the speed is 2, and you can see at the point P, the speed is 1.83. Isn't it? Okay. So that's the answer for part B. Okay, so next I'll be attempting question number 2. So let's see, a particle P is moving in a straight line with simple harmonic motion. The period is pi over 3. The period is pi over 3 means this is the time taken to complete one complete oscillation. So that is pi over 3, and P's maximum speed is 6 meters per second. The center of the oscillation is O. Guys, can you see? So you can quickly mark it on a diagram. So the center is O, and you know the maximum speed occurs at which point? Always remember, the maximum speed occurs at the center. Okay, and they say here the period of the motion is pi by 3. They're asking us to find the amplitude. Okay, so periodic motion, the capital T is pi over 3. We also know the period of the oscillation is given by what? 2 pi over omega. So let's use T equal 2 pi over omega. So periodic time is pi over 3 equals 2 pi over omega. Do you recall? Pi cancels out and omega becomes Omega comes down up over here. 3 times 2, omega answer is 6. Do you agree? So omega, the constant value of omega is 6. Now what do we do? They're asking us to find the amplitude. So which equation am I going to use to find the amplitude? Amplitude is just a constant value, right? Which equation is the best out of this whole lot to find the amplitude? We'll be working with the first one. Obviously, I'll be using v square equal omega square a square minus x square. And what will I use for v and x? We know the maximum velocity occurs when what? We get the maximum velocity when x is 0. The maximum velocity occurs when x is 0. So you can write here the velocity is 6 when x is 0. So this is what you will be using. So 6 square equal omega square. Omega is also going to be 6 square, right? A square minus x square is 0. So you can see here it's 36 equals 36 a square, which gives you what? A square equals 36 divided by 36 is 1. So a equals root 1, which is 1. A is a distance, so it should be positive. So we are going to take the positive value of x. Okay, so just the magnitude. Because you can have, so a is just the amplitude. Okay, is that clear? Amplitude value is 1. Okay. And then they ask you in part B. Okay, they ask you in part B. The speed of P 0.3 seconds after passing through O. So how do you find the speed of P 0.3 seconds after passing through O? Which equation are you going to use? Go through the equations. Which equation? The thing is, you need to find the speed 0.3 seconds after passing through O. So which means you are starting your motion at the center. Do you agree? Do you agree that when they say the speed of the particle 0.3 seconds after passing through O means your particle at time 0 was at O. And then I want the speed 0.3 seconds later. So how do I get the speed 0.3 seconds later? Okay, so to do this, there are two ways. I'll be showing you two ways to do this question. Okay, so the first way is the slightly longer method, but you'll be able to understand that really well. So what's the first method? In the first method, let me do it over here. Okay, I'll bring the equations in part B. Okay, they say the speed of the particle 0.3 seconds after passing through O, right? So which means at time 0, you are at the origin. Do you agree with me? At time 0, we are at the origin. So 0.3 seconds later, where are we? So if you're at the origin, I think you can see there were two equations that they used over here to describe the displacement. So there were two equations, and these two equations are used with respect to where the particle is placed at the beginning. So if your particle at time 0, at the time 0 instance, if your particle is at the center of the oscillation, you are supposed to use x equals a sine omega t. At the start of the motion, when time is 0, if your particle is at the amplitude, you're supposed to use x equal a cos omega t. Now, in our situation, in this sum, where do we find the particle at the beginning? At time 0? At time 0, we find the particle at the center. Isn't it? So we can use what? We can go with the equation x equal a sine omega t. So you can see over here, there are several variables that we know. What are they? Okay, x value, I don't know. I want to find, actually what I'm trying to do is I'm trying to find the displacement after 0.3 seconds. So what is the amplitude? The amplitude value, did we find it? Yes, the amplitude is what we found in part A. What was the amplitude? The amplitude was 1. In part A, we found the amplitude of the motion. The amplitude of the motion is equal to 1 meter. So we can go A is 1. Sine, what's omega? Omega value is 6. And what about t? T is 0.3. Guys, you need to understand when your angles comes in terms of times, in terms of length, or in terms of some real world units, you need to make sure your calculator is in what mode? Your calculator must be in the radian mode. So with the calculator in radian mode, okay, so you will give the value 1 sine 6 times 0.3 in the calc. Can I know what the x value you get? So basically sine 6 times 0.3. So that is 0.3. 97384763. It goes on. Can you see it goes on? So this is not what I want to find. The question, the question they are asking me to find the speed. How do I get the speed now? Which equation do I need to go to get the speed? Obviously, the equation for speed will be v square equal omega square a square minus x square. Do you agree? Okay, so what's the velocity? V square. So the velocity is what I'm trying to find. Omega is 6. Remember, omega is a constant. Guys, you need to understand in these sums, omega and a are constants. Only v and x are the variables. Remember, omega, when you find the omega in the sum, it doesn't change from part to part. Omega is a constant throughout the entire sum. Okay, that's really important. So 6 square, a square, amplitude is 1, right? 1 square minus 0.97384763 square. So let's get the answer. So 6 square into 1 square minus 0.97384763. 7384763. So you can, or you can give answer square in the calc. Okay, and then you get, I get some figure called 1.858334. It goes on like that. 85834856 it goes on. Okay, it goes on. And then, so this is the v square value, right? I get the v square answer in this manner. And then square rooting. Square rooting gives me the answer for the velocity as 1.36321. So correct to 3SF, 1.36 meters per second. Correct to 3 significant figures. So this is the speed. This is the speed of the particle 0.3 seconds after passing through A. So this is the first method. This is method 1. I have a second method also to show you how to find the speed at time 0.3 seconds. So the second method, let me show you the second method. In method 2, what I'll be trying to use is, okay, the thing is I want to find the speed, right, directly. Now you can see to get the speed when you look at these equations, do we have a direct relationship between the speed and the time? I think you can see the first equation has a relationship between the speed and the displacement. But none of the equations we have over here has a direct relationship between speed and time. Do you agree? I have relationship between the velocity and speed and displacement, between time and displacement, but not between speed and time. So guys, what I'll be doing here is, if the particle starts at the center, we can we measure our displacement by using the equation x equal a sine omega t, isn't it? They have told you if your particle is at time 0, if your point is at the center of the oscillation, we use x equal a sine omega t. Do you agree? And now what I want you to do here is, I want you to differentiate. So do you recall what happens when you differentiate displacement with respect to time? Differentiate displacement with respect to time, and what do you get? We can write this as x dot, or in other words, dx by dt. So when you differentiate, what do you get here? A sine omega t. A is the constant. Sine differentiation is, the differentiation of sine is, cos omega t, and then into, you have to multiply with the chain rule. You have to multiply with omega again, isn't it? Do you recall? So P3 differentiation, A cos omega t. So sine differentiation is cos, and then omega t differentiation is omega. Agreed? So this is the x dot is the speed. So it's A omega cos omega t. And you can see now we have a direct relationship between the speed and the time. So we know the amplitude. We know omega, the constant omega value was found in the previous part. And they have told us to find the speed when time is 0.3. So all you got to do is substitute. Amplitude is 1, omega is 6, cos omega is 6, and time is 0.3. So type the whole thing in the calc. With the calculator in what mode? With the calculator in radian mode, and you should be able to get the speed immediately. So you can see in method 2, in the second method, we can get the answer for the speed in one step, like we differentiate and immediately we can get the speed. But in method 1, I had to go through 2 steps, right? I had to find x first and then substitute x into the equation, into this equation to find the speed. So type the whole thing in the cal and let's get the speed. So you can see when you type this in the calculator with the in radian mode, you get the negative sign, isn't it? So you get the negative sign. However, we need the speed, isn't it? We want the speed. Okay, so the negative sign, this is because it's the velocity, so it might be referring to the direction. So anyway, we are only interested in the magnitude, the speed of p 0.3 seconds after passing through O. So basically the speed that we require here is just the magnitude 1.36 meters per second. So you can see I can get the same answer in both the methods. I can get the same answer in both the methods. So, so you can see that you can use either of these two methods to get the answer. So actually method 2 is more preferable because you can get the answer directly with the correct sign. Okay, so here since we are interested in the speed, we just needed the magnitude of this. Okay. Okay, so let me give you a little bit now. This is the answer to the question, but I want to give you a little bit extra information about this negative sign because you might be wondering, we got a negative answer here, right? So at time 0.3, we got a negative sign for the velocity, isn't it? X dot is the velocity. So what does this negative sign mean? Normally we know negative sign. Now this is something extra other than what they've asked in the question. But for you to understand this question properly, I'll be giving you this explanation. So this is really important. Okay, so look what happens here. Normally, what does the negative sign mean? The negative sign means when it's directed towards the origin. Okay, so what they're trying to say here is at time 0.3 seconds, your velocity is directed towards the origin. So we can check on this. How can we check on this? Now I told you, now in this question, you can see they have told us the period is pi over 3, isn't it? Okay, so the period is pi over 3 seconds. What do you mean by pi over 3 seconds? Pi over 3 seconds is the time taken to complete one full oscillation, isn't it? The time taken to complete one full oscillation. Then in that case, can I know the time taken to go from the center to the amplitude? What is the time taken to go from the center to the amplitude? Yes? What is the time taken to go from the center to the amplitude? So you know the time taken to go from the center to the amplitude is what? I told you previously, it's a quarter of the periodic time, isn't it? Now periodic time is the time taken to go all the 4 parts of the SHM, right? I told you SHM you can take into 4 parts. Center to amplitude, again amplitude to center, and center to the other amplitude, and amplitude to center. Okay, so it's divided into 4 equal parts. So then the time taken from the center to amplitude is a quarter of the periodic time, isn't it? And the time taken again from the amplitude to the center is also again the same amount, a quarter of the periodic time. Now I want you to calculate me this value. What's T over 4? We know that the periodic time is pi by 3, right? So what is T over 4? What is T over 4? Can you divide pi over 3 by 4? How much is the answer? Get the time, get the actual time. A quarter of the periodic time. 1/4 of pi over 3. You get pi over 12, which if you convert it to seconds, which you give, if you get the decimal figure is 0.261799 seconds. Do you see? So basically, you take how many seconds to come from the origin to the from the center to the amplitude? To come from the center to the amplitude, you take 0.261799 seconds. Can you see? So now they are asking us to find the speed at how many seconds? At 0.3 seconds. So you need to realize when 0.3 seconds pass, okay, are you in the initial part of the journey? No, you have actually gone to the amplitude and you're probably on your way back. Isn't it? Do you realize that you're on your way back? Okay, so at t equals 0.3 seconds, you have already gone to the amplitude and you're on your way back. And you can see at this point, your velocity, velocity is directed towards the origin. Do you agree? At time 0.3 seconds and over here at time 0.3 seconds, you're actually on your way back towards the origin because the time taken to go from the center to amplitude is 0.2617 seconds. So 0.3 seconds means you have passed the amplitude and you're on your journey back. Then that's why, and that's the reason why what? Your velocity here is, the x dot value here is negative. Okay, but we just want the speed, so we just have to get the magnitude of it. Okay, so moving on to question number 3. A particle P is moving in a straight line with simple harmonic motion. Its maximum speed is 10 meters per second and its maximum acceleration is 20 meters per second square. Calculate the amplitude of the motion and the period of the motion. How do you do this? So I think you need to recall now. I have given you the information you require. So where do you have the maximum speed? Always maximum speed is at the center, Vmax. You have the maximum speed is 10 meters per second. This occurs when x is 0. And the maximum acceleration, the x double dot maximum is 20 meter per second square. I think you get the maximum acceleration at the amplitude. Okay. So all you have to do is to get a pair of equations to find the amplitude. Okay. So let's get it. So they say here to find the amplitude and they are asking you to find the period. Okay. So what do we use here? So shall we go when Vmax is 10, x is 0, we can go for the equation V square equal omega square a square minus x square. Agreed? So when V is 10, omega is a constant, amplitude is a constant. Omega is a constant, amplitude is a constant, minus x is 0. So I think you can see we get the equation 100 equals omega square a square. Guys, do you agree? This is one equation we can create. The other one we can create here is by using what? By using the equation for acceleration. So what is the acceleration equation? Acceleration is minus omega square x. Now we know this minus mark is there to simply show what? To show that the acceleration is directed towards the center. Right now, all I need is the magnitude of the acceleration. So what is the size of the acceleration? The maximum magnitude of the acceleration is 20. So just take the magnitude of it. Are you with me? Take the magnitude of the acceleration, which is 20. So 20 equals to omega square. You don't need the negative sign. And what is x? You get the maximum amplitude when x is? You get the maximum amplitude when x is a. When x is a. When x is 0, you are at the center. When x equals a, a is the amplitude. When your displacement equals to amplitude, you are at the corner. You are at this point over here. So x is equal to a. Okay, so x double dot equal omega square. So removing the minus, it's omega square times x is a. So it's a pair of simultaneous equations. So divide. I think we can go for the division. Divide the equation 100 divided by 20 equal omega square a square over omega square a. So you can see omega square completely cancels out. So 100 divided by 20 is, do you agree? 100 divided by 20 is 5. A square divided by a is a. So which means what? I get my amplitude is equal to 5. Do you agree? Amplitude is equal to 5. And from the amplitude, so in part B, then they ask you to find the period of the motion. How do you find the period of the motion? Period of the motion T is, what's the equation? T equals to 2 pi over omega. So that's the equation that you should know, that you need to remember. So you can see 2 and pi are constants. Omega is a constant which must be found. How do you find the value of the omega constant? You can use the help of either equation, the first equation or the second equation. So how do we do this? We can go for the second equation. 20 equal omega square times a. So 20 equal omega square. A is 5, right? Omega square is 20 divided by 5, which is 4. So omega is equal to root of 4, which is 2. Take the positive constant. And now, because periodic time should be positive, right? So omega should be definitely positive. So T equal 2 pi over omega. So 2 pi over omega is 2, which means it's 5 seconds. Periodic time is 5 seconds. Okay.